Hello, and welcome to Daily Space Facts. Today, we take a trip to TRAPPIST-1c, in the constellation Aquarius. 40.7 light-years from Earth, lies a quiet, ultra-cool, red dwarf star. And a family of 7 Earth-sized worlds, locked in a cosmic dance. One of them was long thought to be our solar system's evil twin, a scorching, Venus-like planet. But recent revelations from the James Webb Space Telescope tell a different story. This is TRAPPIST-1c, the rocky exoplanet that surprised us all. TRAPPIST-1 is no ordinary star. It's an ultra-cool red dwarf, only about 12% the size and 9% the mass of our Sun, with a surface temperature of roughly 2,550 Kelvin. It's so dim that its entire habitable zone sits incredibly close to the star. Here, the planets orbit in tight resonance, like a perfectly tuned clock. TRAPPIST-1c, the second planet out, whips around its star every 2.42 Earth days at a distance of just 0.0158 astronomical units, closer than Mercury is to our Sun, yet because its star is so faint, TRAPPIST-1c receives only about 2.1 times the energy Earth gets from the Sun, almost exactly the same amount Venus receives. At first glance, TRAPPIST-1c seemed like the ultimate exoplanet analog to Venus, a super-Earth, slightly larger and more massive than our world, but receiving similar stellar heat. Astronomers wondered, does it have a thick, crushing carbon dioxide atmosphere? Sulfuric acid clouds, a runaway greenhouse? Hell, its density is strikingly Earth-like, suggesting a predominantly rocky composition with an iron-rich core. Gravity is close to Earth's, but its year is just 58 hours long, and it's almost certainly tidally locked, with one side forever facing its star in blistering daylight, the other in eternal night. Then, in 2023, the James Webb Space Telescope pointed its powerful infrared eye at TRAPPIST-1c during secondary eclipse. When the planet passes behind its star, Webb detected the faint heat radiating from the planet's dayside, and measured a brightness temperature of about 380 Kelvin, roughly 107 degrees Celsius. That's hot, but far cooler than expected for a Venus-like world with a thick CO2 blanket. The data ruled out a thick carbon dioxide atmosphere at high confidence. No Venus-style runaway greenhouse. No sulfuric acid clouds. Instead, TRAPPIST-1c is likely a bare, rocky surface. Or possibly a very thin atmosphere, perhaps dominated by oxygen. This makes TRAPPIST-1c the coolest rocky exoplanet ever characterized by direct thermal emission. And it hints at something deeper. The TRAPPIST-1 system may have formed with fewer volatiles, less water, less carbon, than we hoped. If TRAPPIST-1c, receiving Venus-level energy, couldn't hold on to a thick atmosphere, what does that mean for the potentially habitable worlds farther out? The inner planets may have lost their atmospheres early on due to the star's intense youth phase radiation, or they simply formed in a volatile poor disk. Future JWST observations of the full orbits will reveal day-to-night temperature swings, and give us even clearer answers. TRAPPIST-1c may not be a second Venus, but it's teaching us how rocky worlds evolve around red dwarfs, the most common stars in the galaxy. TRAPPIST-1c reminds us that every exoplanet has a story, sometimes different from the one we expected. As we continue exploring this remarkable system, we edge closer to understanding whether life-friendly worlds can truly thrive around small, red stars. The universe is full of surprises, and TRAPPIST-1c is just the beginning. Thanks for watching. Like and subscribe. Join us again sometime for more epic journeys into the cosmos.